For examples 3 and 4, we have a couple of quick hitters here. These are taking a look at more, call them lab-like applications of some of the things we use to test the stoichiometric method. So here we have a student performs a reaction that produces silver chromate. Awesome. Using stoichiometric calculations, she expects to get 1.4 grams. This is her expectation of what she should produce in the lab. She then filters her precipitate, dries it, and weighs the product, and finds out that the mass is only 0.9 grams. We're being asked to figure out the percent yield, which is the efficiency of collecting the target mass. Okay, so we have a formula for that one. And so we see percent yield as just a ratio of the actual versus, can't write tonight, predicted masses that we were supposed to get. Predicted, again, remember, is stoichiometry. That is what it's giving you. Actual or experimental is another word that we could substitute into here, which is what we got in the experiment. So we just have to fill this one out. And her actual amount was just 0.90 grams. What is her predicted amount? Well, she expected to get 1.40 grams. So you can see that she got quite a bit less than what she wanted. How much did she get? Percentages are usually great ways of trying to figure out how close or far you are from a target or an expectation. All right, you thought you did really well in a quiz and you were hoping for an 80 and you got a 63. Oops. Okay, there's a bit of a difference from here between actual and what you'd hope for or predicted. So same idea here. Percentages just make a great way of allowing us to visualize this one. And so when you run the two numbers, you get 64.28%. This is still a number governed by sig-digs like anything else, and 2 sig-digs is our limit. So she had a 64% yield or a 64% efficiency on getting the product that she had. She should probably go back and evaluate her laboratory techniques and her experimental design and her procedure and start looking for ways to avoid such big losses. All right, if stoichiometry says 1.4, realistically, she should be able to get there. Okay, here's another little quick hitter here. It's got a few points to it or a few parts to it, but we're using gravimetric stoichiometry again, and we calculate the mass of precipitate to be 6.67 grams in a chemical reaction. All right, this is my stoichiometric prediction. All right, I'm using stoichiometry, and it says I'm supposed to get this. Using the filtration technique, oh my goodness, you collect and measure the mass of precipitate to be slightly less at 6.49. So in this case, we're actually evaluating the stoichiometric method more than looking for an efficiency. They're really similar calculations, but what we can do here then is go through and do a percent difference. How far from 6.67 are we? Okay, so percent difference is just equal to the experimental value minus the predicted or theoretical value, all divided by, whoops, I should stay consistent with my terms, all divided by my predicted. And then again, I multiply by 100. So this is now going to give me a percentage away from my target, not a percent closer to it, but a percent away from it. It's just kind of the way we look at difference when we get into higher levels of science. And so the experimental value we got was 6.49. The predicted value, however, was 6.67. And we want to compare this difference. There's the difference. It's why I like this rather than error. You're taking a difference between your two numbers and comparing it to a target. Okay, and when we work this one out, you can see the 3 sig dig limit, so I'm just going to save some space here. Works out to be negative 2.70%. Now, I know some teachers will tell you to use the absolute value bars for this one and just say, hey, it's 2.7% different. I'm a different philosopher in this one. I believe that the negative helps pick where your errors might lie. This one says you are below the target by 2.70%. So, is the prediction verified? Well, what is our percentage difference limit for most of these problems? Good memory, 10%. We are 2.7% different. That is well within the limits here, so our prediction is verified. Is there anything we could do to improve the validity as we are looking for an evaluation? And I would say not much. Okay, you have a very nice percentage difference here. Unless something happened in the production of your lab that had you really, really worried, then no, this one seems to be working out just fine. What this percentage difference ends up suggesting for us that the experimental design is quite valid. That in this case, the filtration technique that she was testing does work, or the gravimetric stoichiometry prediction for filtration technique does work. The previous question, our experimenter had some problems that she needs to go look at because of that low efficiency. This, however, with only 2.7% difference, is over 97% efficient, and so no, this one was a much better experiment. Looking at my time on the video here, I'm going to take way more than 3 minutes to try and get through this one. So try to come up with a balanced chemical equation before you look at the next video, and then we'll go through this solution.